So let's continue on with hypothesis testing. We need to choose a null and alternative hypothesis pair before we can proceed. So there are three different alternatives. You have to decide what kind of thing you expect to see instead of the usual thing. So if we were talking about our potatoes, the null hypothesis might have been mu is 10.3, and the alternative was your suspicion that they're shorting us on the size of potatoes. The mu is probably less than 10.3. That was 10.3 ounces, I guess. Pretty heavy potato, I'm thinking. Stating conclusions. At the end of the process, we report one of two things. The first one we might say is the results are considered statistically significant, and we reject the null hypothesis. Statistical significance means we wouldn't see that value of x bar if the null hypothesis was true. Or second, the results are not considered statistically significant, and we fail to reject the null hypothesis. Not statistically significant means the value of x bar that we see is quite possible if the mean is the quoted value. So in our potato example, if we got a value of x bar close to 10.3, we'd have no reason to disbelieve the idea that the mean is 10.3. When the value of x bar is unlikely to occur by chance alone, we call the result statistically significant. I'm restating it. In this case, we reject the null hypothesis that mu is the given value. We conclude that the null hypothesis is rejected, and the alternative hypothesis, has been accepted. So since you have three different kinds of alternatives, the only reason you would accept this alternative that the mean is less than 10.3 is if you saw evidence that the mean is smaller than 10.3. If that's what you're looking for, you don't reject the null hypothesis if you're looking for a mean less, if you get a mean greater. That's pretty much how it works out. Alright, so we've made it through 2 slides. I don't know how many there are. It's probably an infinite number. I'll be back in a minute with another one.